afternoon everyone, I'm Asimwe Herbert, and in today's video I'm going to teach you how to find the mean and the variance of the negative binomial distribution. Be blessed as you watch. So we are going to deal with the negative binomial distribution, and the mass function is given as follow, where your x is from 0, 1, 2 up to infinity, and we know that our probability is always in the middle of 0 and 1, does not exceed 1. So we are beginning with the mean. I know that our mean Ex is always equal to the summation of x, then the probability of x equals x, which is r plus 1 minus 1 chooses x, PR 1 minus p to the power x. P is probability of success, 1 minus p is probability of failure. So this is from Rx equals 0 up to infinity. So we are going to first deal with this term only. So which is x, r plus x minus 1 chooses x is equal to x. So this is r plus x minus 1 factorial over x factorial r minus 1 factorial. So you know our x factorial is always x minus 1 factorial. So an r factorial, it will be r minus 1 factorial. That means my r minus 1 factorial, if I make it the subject, it is the same as r factorial over r. That means this is x, r plus x minus 1 factorial over my x factorial, which is x minus 1 factorial, and my r minus 1 factorial, which is r factorial over r. This and this go, and when I'm to divide this, I end up with r plus x minus 1 over x minus 1 factorial, r factorial, and this one gives me r into r plus x minus 1 chooses x minus 1. This is giving us this one. Observe critically combination of this. So we have our mean e of x. It is going to be now summation. Now the whole of this term, it is this, which is r plus x minus 1 PR 1 minus p x. This is to infinity, and it's beginning from x is equal to 1. So we know that this is a constant, so we are going to pull it out. So we have our r, x is equal to 1 up to infinity, r plus x minus 1 x minus 1 PR 1 minus p x. So you know that the probability mass function always adds up to 1, which is this. So we are going to try to change this into this. So here we can say maybe our y is x minus 1. That means my x is y plus 1, and we may say our q is r plus 1, and means my r, it is q minus 1. So this term x plus r plus x minus 1, that means it will be my r, which is here, which is q minus 1, plus my x, which is here, which is y plus 1 minus 1. You see this is going away, so we stay with q plus y minus 1. That means you have r summation. So the whole of this is this, which is q plus y minus 1, and our x minus 1, we said it is y, chooses y, then p r, where my r is q minus 1, 1 minus p, and my x is y plus 1. So since we have changed this x and I've changed it into y, and this is beginning from y equals 0 up to infinity. So from here I have r, this is y equals 0 up to infinity, q plus y minus 1 y. Remember, we are trying to transform this into a probability mass function, so we shall have our p power q, then p to the power negative 1. I think same base, when we add the power we get exactly this. The same applies here, which is 1 minus p to the power y, 1 minus p to the power 1. Also same base, we shall add, and then we shall fall here. So when you look here critically, we have this as a constant, even this as a constant, so we pull them out, so it will be r 1 minus p. Now this is p to the power negative 1, p to the power negative 1, and then the summation from r equals 0 up to infinity, q plus y minus 1 chooses y, and we have our p to the power q, then 1 minus p to the power y. So if we are to observe critically, we are seeing that this it is looking exactly as this, which gives us a 1. That means the whole of this is giving us 1. That means our mean, it is r 1 minus p, p negative 1, and you can write it nicely to look good in your eyes, which is r 1 minus p over p, and this marks to the end of our mean of a negative binomial distribution. So we are going, after us finding our mean, we are going to find our variance. And we are still working with our mass function, which is r plus x minus 1 chooses x, pr 1 minus p chooses x. Now we know that our variance of x is given by e of x squared minus the mean squared. So this can be written as e. This is the same as x squared minus x plus x, then minus e of x. I think I've not changed anything here, because this one brings us back here again. This one can be the same as written as e. Now this can be as written as x minus 1, then plus e of x minus e of x squared, where our e of x is the mean which we found, and then we have our task is to find this. So our e x minus 1, it will be the summation from rx is equal to 0 up to infinity. Now we have x minus 1, then our probability, the function, which is r plus x minus 1 chooses x, then pr 1 minus p to the power x. So even here we are going to first deal with this term. So if I have my x minus 1, r plus x minus 1 chooses x, this is the same as x minus 1, r plus x minus 1 factorial over x factorial r minus 1 factorial. So here our x factorial, it is given by x minus 1 x minus 2 factorial. Here on the variance we shall end at our x minus 2. Then our r factorial, and it is always r minus 1 r minus 2 factorial. But here our r minus 1 factorial, we shall get it from actually r plus 1 factorial, which is always r plus 1 r minus 1 factorial. So my r minus 1 factorial, it will be r plus 1 factorial over r plus 1 r. So we come here, this is the same as x minus 1 r plus x minus 1 factorial over, now our x factorial is here, it is the same as x minus 1 x minus 2 factorial, and my r minus 1 factorial is here, and it is the same as r plus 1 factorial over r plus 1 r. So you are seeing this and this are going, this and this are going, and if you to divide this, it is the same as r plus 1 and this r, then r plus 1 minus 1 factorial over, we have x minus 2 factorial r plus 1 factorial, and we want to look at this, it is the same as r plus 1, this is the same as r plus x minus 1, chooses x minus 2, because this gives you the combination, this one is the combination of this. So our summation x minus 1, it is going to be our summation. Now the whole of this term, it is this, which is r plus 1, then we have r plus